Okay, now you have x into root 8 minus x square from 3 to minus 3. Let's see what we have. 3 to minus 3. 8 minus x square. So maybe we can take 8 minus x square be equal to, say, t. So minus 2x dx is equal to dt. Therefore, x dx is equal to minus dt by 2. Also, simultaneously, we have x and t. We need to change the range. So when x is 3, t is going to be 8 minus x square. Now we are going to find out something. 8 minus x square. What is that? 8 minus minus 3 square, which is going to be minus 1. When x is minus 3, is going to be 8 minus minus 3 square. 8 minus 9, again minus 1. So if you look at it, it's going to be from minus 1 to minus 1. And it is going to be minus half into 1 upon root t dt. Now there is no need to calculate anything. It is like telling you're finding the value of it from here to here, which eventually is going to be 0. Whatever you do, there is no need to integrate it all. Another thing that is there is, if you see, this is an odd function, f of x. Just in case you don't get it, you may end up doing this way, and eventually you're going to get it as 0, because whatever you get, minus 1, minus 1. So it's going to be x into root 8 minus x square. Now f of minus x is going to be minus x into 8 minus minus x square, which is going to be minus x square. So you see that f of minus x is nothing but minus of f of x. So it's an odd function. So the value, and it is from 3 to minus 3, that is a to minus 3. So we are using the rule f of x dx from a to minus a is 0 if function is odd. But just in case it doesn't strike you to go about doing it, you can do it the same way as we have done by substitution, and you find that the domain is from minus 1 to minus 1, and the domain is, both the extents are the same. Obviously there is no area covered below that curve, so you can take it as 0 itself. So the answer is 0. Okay. Similarly, here you have 1 to 0, 1 minus x plus x, integral of this. Okay. So it's 1 to 0, 1 minus x upon 1 plus x. Now, if you see, we can write this as 1 to 0, and we can write it as 1 can be written as 2 minus 1 minus x upon 1 plus x. This can be then written as integral of 1 to 0, 2 upon 1 plus x minus plus, okay, let's do it, minus of 1 plus x upon 1 plus x dx from 1 to 0, which is going to be 2 log 1 plus x from 1 to 0 plus minus dx from 1 to 0. So it's going to be 2 log 1 plus 1 minus 2 log 1 plus 0. This is coming to this, and this is nothing but x from 1 to 0. Now this is nothing but 2 log 2 minus 2 log 1, which is nothing but 2 into 0 minus 1 minus 0. So it's going to be 2 log 2 minus 1. So it's going to be 2 log 2 minus 1. If you look at the whole thing, you found it as 2 log 1 plus x. minus dx, which is going to be nothing but minus x from 1 to 0. This is going to be minus 1 minus 0. This is going to be 2 log 1 plus 0, 2 into 0. So it's 2 log 2 minus 1. That is option number A. Okay. Then you have absolute value of x upon x. And it's again, the moment you get this kind of a question, a to minus a, perk up. It could be an odd function. They expect you to answer like this. So it's going to be upon x. Now this is f of x. Okay. F of x is absolute value of x upon x. Now f of minus x is what? Absolute value of minus x upon minus x, which is nothing but eventually absolute value of minus x and absolute value of x are one and the same, but this is going to become minus x. That means f of minus x is equal to minus of fx. Therefore, it's an odd function. And we know that in an odd function, f of x dx from a to minus a has to be 0 in case of an odd function. Now, since this is an odd function and the range is from a to minus a, the value of this function has to be 0. Okay, so let's check. Okay, alright. Now you have dx of ax plus b into 1 minus x the whole square. This again we have to check what it is. We can take ax plus b into 1 minus x as, say, t. So you find the derivative of this. Derivative of ax is a plus b into 1 minus x. So it's going to be a plus b into 1 minus 1. So we'll do the thing. So it's going to be ax plus b minus b. So it's going to be ax. You're finding the derivative. So it's going to be a plus b, its derivative is 0, minus bx, the derivative is minus b, which is going to be dt. So a minus b dx is equal to dt. Right? A minus b dx is equal to dt. Now let's come to, that means dx is going to be dt upon a minus b. Now let's see the range when x and t. Remember, a and b are constants. When x is 1, what will t become? A into 1 a plus b into 1 minus 1 0 will become a. And when x is 0, a into 0 0, b into 1 minus 0 b, so it's going to be b. That means eventually it is going to be 1 upon a minus b dt from 1 to 0. So it's going to be from a to b. And what is this? T. So it's going to be t square. So it's eventually 1 upon a minus b into t cube by 3 from a to b. So this is now going to be equal to 1 upon a minus b into a cube by 3 minus b cube by 3. So let's check dt upon a minus b into b. Oh, sorry, we made a mistake. It's t raised to minus 2, which is upon t. So it's going to be minus 2 plus 1, that is minus 1 upon minus 1. So it's going to be, we made a mistake here because it is in the denominator. So it's going to be, ultimately this will be 1 upon a minus b. In fact, it's minus 1 upon t raised to minus 1. That is 1 upon a minus 1 upon b. Is going to be minus 1 upon a minus b into b minus a upon ab. Sorry, a into b. So this is going to be again minus b plus a. So it's going to be a minus b upon a minus b into a. This gets cancelled and ultimately you're getting 1 upon a. Just would like to clarify once again, when we did this, I took by mistake, it's dx upon ax plus b raised to 1 minus x. So it's going to be 1 t raised to minus 2 dt, which is going to be t raised to minus 2 plus 1 upon minus 2 plus 1, which is going to be t raised to minus 1 upon minus 1, which is minus 1 upon ab upon 1 by t. Okay, so that is going to be 1 upon a minus 1 upon b. And then you simplify it and you get this. So ultimately it's going to be 1 upon ab. Okay. Okay. Now we have something over here, log ex raised to n upon x. So we have, let's simplify this. Ex raised to n is nothing but e to the base e plus log x to the base e the whole raised to n, which is nothing but 1 plus log x the whole raised to n. So it's eventually 1 upon x into dx. So we can take, let 1 plus log x be equal to t. So therefore if you take derivative, we get dx by x is equal to dt. Now hence now we need to also find the domain. Now we took the, for x it was from 2 to 1. So for t it is going to be what? T is nothing but 1 plus log x. So when x is 2, it is going to be 1 plus log 2. And when x is 1, t is going to be 1 plus log 1. That is 1 plus 0, 1 itself. So the whole thing will change to 1 plus log x raised to n, which is nothing but t raised to n. Dx by x is dt. So dx by x is dt. In the domain 1 plus log 2 to 1, which will be eventually t raised to n plus 1 upon n plus 1 from 1 plus log 2 to 1. So let us substitute here. We are not, students don't do the mistake of substituting. Instead of n, it is 1. There seem to be two unknowns. Our variable is t, not n. So it's eventually going to be 1 plus log 2 raised to n plus 1 upon n plus 1. That is, instead of t, you are substituting this, minus 1 raised to n plus 1 upon n plus 1. So if you simplify this, 1 raised to n plus 1 is nothing but 1. This 1 can again be written as log e plus log 2 raised to n plus 1 minus 1 upon n plus 1, which is nothing but log e plus log t is log 2e to the base e raised to n plus 1 minus 1 the whole upon n plus 1. So it's eventually log 2e to the base e as it was in the question raised to n plus 1 minus 1 upon n plus 1. So what have we done? We have split up this log e to the base e as e and log x to the base e. So eventually it's 1 plus log x to the base to the raised to n upon x dx. So we took 1 plus log x st, so dx by x is t, and when x is 2, t becomes 1 plus log 2. When x is 1, t becomes 1 plus log 1, that is 1 plus 0, 1. So eventually on substitution, we end up getting, since we have taken this st, you get t raised to n. Dx upon x is nothing but dt, and the limits have changed from 2 to 1 to 1 plus log 2 and 1. Now this is nothing but t raised to n plus 1 upon n plus 1. Instead of t, you put 1 plus log 2 raised to 9 plus 1 upon n plus 1. Again, for the lower limit, it's going to be 1 raised to n plus 1 upon n plus 1. Again, the 1. Why do we change this to 1? Because the question is given in those terms. So it's going to be 1 plus log 2, which is going to be log e plus log 2 raised to n plus 1 minus 1 raised to n plus 1 is minus 1, which will eventually be log 2e to the base e. Actually, all these should be to the base e. Should be to the base e. So it's log 2e to the base e raised to n plus 1 minus 1. This is the whole divided by n plus 1. So it's option number A. Okay, yes, okay. Again, here we have evaluate 2x square minus x cube dx, and the value is so and so. So it's nothing but, it's going to be 1 to 0. 2x square is nothing but 2x cubed by 3 minus x raised to 4 by 4, which is going to be 2x cubed, 2 into 1 cube, 2 by 3 minus 1 raised to 4 minus 1 by 4. Taking LCM, you get 12, 4 2s are 8 minus 3, so it's going to be 5 by 12. There is no constant involved over here, so it's going to be 5 by 12. Okay. Okay, here we have 3x minus 2 the whole square dx, and the value is so and so. So now, what is the value that has been asked? 3x minus 2 the whole square. So this is nothing but 3x minus 2 the whole cube by 3 from 4 to 2, which is going to be 3 into 4, 12 minus 2, that is 10 cubed by 3 minus 3 into 2, 6 minus 2. 6 minus 2 is nothing but 3 2s are 6 minus 2. It is going to be 64 by 3, which is going to be 1000 minus 64 by 3 by, sorry, it's going to be 9, right? Yeah, and we have also forgotten one thing, into 1 by 3, because the derivative of this, so it's going to be upon 9. We have to find the derivative of, you have to divide it by the derivative special variable, so upon 1 by 3, it's going to be 936 upon 9, which is 104. Now this is a kind of mistakes candidates do tend to make, and often they tend to think, okay, where have I gone wrong? But the problem is lying here, so you're taking it as 3x. You could do another way, you can expand it using a square minus 2ab plus b square, and then get it done. Even that should be fine. So it's going to be 104. 104. Okay. All right. Evaluate 1 to 0. So we're going to use the integration by parts here. So it's going to be, first let us integrate x into e raised to x dx. It's going to be in LAE, so logarithmic, there is no logarithmic function, there is algebraic and then exponential. So algebraic will be taken as u, so x into e raised to x dx. Okay, so we can take it as 1 to 0 to just get the constant, minus integral 1 to 0 d by dx of u, that is of x, into integral of e raised to x dx and dx, which is going to be x e raised to x from 1 to 0 minus d by dx of x, which is 1. Integral of e raised to x dx is e raised to x itself into dx. And this is going to be x e raised to x minus e raised to x from 1 to 0. So it's going to be 1 into e raised to x, that is 1 into e raised to 1 minus e raised to 1 minus 0 into e raised to 0 minus of minus plus e raised to 0. So it's going to be e minus e minus 0 plus e raised to 0 is 1. Now this e and minus e will get cancelled and 0, ultimately you're left with only 1. So the answer is 1 plus 1. Okay.